Okay, geometry fans, our topic for today is pyramids and cones. So we're looking at three-dimensional objects. And for today, we're going to do the work off of this worksheet. We've got two examples that we're going to take a look at. The first one here is your pyramid, and the second one is the cone. So before we do that, though, let's talk about the formulas. So this formula sheet here, this has got the area formulas, it's got volume on it. We've already looked at the prism. So they draw a triangular prism, but this is for any kind of prism. There's your volume formula, area of base times height. There's your lateral area, the height times the perimeter. And the surface area is your lateral area plus two bases, 2 times the area of the base. And then this is your rectangular prism here. Okay, so those are the prisms. We've also talked about the cylinder. So volume, lateral area, surface area. So for today, let's talk about the cone and the pyramid. So we'll start with the pyramid. And a couple things that you'll notice right away are different about a pyramid compared to a prism. A prism has 2 bases, but a pyramid has only 1 base. So a pyramid, this time we're only dealing with 1 base. Now the other thing that happens is that if you look at the lateral faces, those are the faces that are connected to the base. They're not rectangles like in a prism. Okay, come back to the prism here. So those are all rectangles. But what happens in a pyramid is they will all be triangles because all the lateral faces meet at this one point, which is called the vertex of the pyramid. So this is going to be a little bit different from the prism. Starting with lateral area, okay, I'll come back to volume in a second. The lateral area is 1/2 times L times P. Now the L, this is going to be a new variable, that's called the slant height. The slant height, and then the P is the perimeter of the base. P is perimeter of base. Alright, so what do I mean by the slant height? Well, when you look at the pyramid, so you've got the base, and then the faces, they're not going straight up and down, the faces all slant so that they can meet at the vertex here. And because these are triangles, if you were trying to find the area of the triangle, that's 1/2 times the base times the height of the triangle. So we actually need this height of the triangle. But the height is not perpendicular up and down, which is what you're used to. This is a height for the pyramid itself, this H. This H is the height of the pyramid from the vertex down to the center of the base. That's the height of the pyramid. So the height for the pyramid. The slant height is going to be the height of the triangular faces, the lateral faces. So that L right there, that is your slant height. So when you're talking about height, you have to be very careful which one you're looking at. For lateral area, it's going to be the slant height. And then P is the perimeter of the base. So you'll notice that going back to the prism, the lateral area is the height times the perimeter. For the pyramid, the lateral area is half the slant height times the perimeter. And the reason you have the 1/2 is because when you find the area of a triangle, it's 1/2 base times height. The surface area is your lateral area, the 1/2 L times P, that's lateral area, plus 1B. Notice that for the prism, you have 2 bases. So you have to have the area of both bases. But for the pyramid, you only have 1 base. And then for the volume, it's 1/3 times the area of the base times the height. Okay, so the formulas are a little bit different. They're related, but they're different. So let's take a look at the example. We'll take number 1 here on this worksheet. So find the lateral area, surface area, volume of the pyramid. Well, so I'm going to write down the formulas as we go here. LA, lateral area is 1/2 times slant height, that's the L, times the P. Now in this problem, they actually give you the slant height. So that's the height of the triangular face. So that's my L, 10. I'm going to put a right angle here. That's going to be perpendicular to this edge. So we know that that's 10. So 1/2 times 10 times the perimeter of the base. Well, the base, in this case, is a square. So 16, 16, and then the back and the left sides are both 16 as well. So I'm going to write down here, P equals 4 times 16, which is 64. And we'll put that into the formula. And now we'll do 1/2 times 10 times 64. You can use a calculator. 1/2 times 10 times 64, and we get 320. So LA equals 320. And let's say they don't tell us what units these are. Let's say this is centimeters. So the lateral area is 320 centimeters squared. Okay, so there's your LA. Surface area is 1/2 times slant height times the perimeter of the base plus the area of one base. So right now we already have the LA, this 1/2 L times P, that was the 320. So what we need is the area of the base. Well, the shape of the base is a square, and the sides are 16 and 16. So area for a square, say ASQ, is length times width, or base times height, 16 times 16, which is 256. So that's the capital B variable right there. So we put that in here, and we add 320 plus 256. So the surface area is 576, again, centimeters squared. And now we need the volume. So the formula for volume is 1/3 times the area of the base times the height. Well, we've got the area of the base. We just found that, 256. The height, though, we do not have. H is not the same as the slant height. The height of the pyramid is this right here. So there's my H. So the problem is that we don't have that yet. What you can do, though, this height creates a right angle when it hits the base. It comes straight down. I'm going to draw, and I'm going to connect the bottom of the height to the bottom of the slant height. And what this does is it creates a right triangle. Now we actually know the length of this bottom leg, because if this is the center of the pyramid and it's 16 across, this will be half that, so that's 8. So what we have is H, 8, and then the 10 is the slant height. And so we've got a right triangle. Okay, we can draw it on the side here. H, 8, 10. And if you want to find the H, let's do Pythagorean theorem. H squared plus 8 squared equals the hypotenuse, which is 10 squared. So this is a very common right triangle. We'll subtract 64, you get 36. And then we take the square root of both sides, and the height is 6. So I'm going to take that 6, and I'm going to plug that into the formula here. So it's 1/3 times 256 times 6. Quick way you can do this is you can take 1/3 times 6, which is just 2. 6 divided by 3 is 2, and then 2 times 256 is 512. Now this is going to be units cubed, because that's a volume. Volume's three-dimensional, so it's the units of measurement raised to the third power. Okay, so that's how you do that problem right there. Notice that you may have to do Pythagorean theorem to find a piece of this. Be very careful when you use the formulas. Write them down, whatever formula you're using, and then just substitute the numbers as you find them. So that's a pyramid. So let's also talk about a cone. So we'll come back to the formula sheet here for a second. Here's your cone. And what you'll notice is you have the same things. You have one base, like a pyramid. The only difference is that the base is a circle. So your formulas, you'll notice you're going to have pi and you're going to have radius because you're talking about circles here. You have, this is the slant height again. You have the height of the cone, that's the straight up and down, that's perpendicular to the base. And then you have, this is the radius. So here are your formulas. So let's go ahead and use those. And we'll do the second example on the worksheet. So find the lateral area, surface area, volume of the cone. So lateral area for a cone is pi times radius times slant height. Now you'll notice we don't have the 1/2 like we did with the pyramid. Well, the reason is that when you find the circumference, the perimeter of a circle, that's 2 pi r. But when we take half of it, because we're dealing with a slant height, that just becomes pi. It just becomes 1 pi times r times L. So lateral area equals pi times radius times slant height. Okay, so do we have the radius in this problem? Yes, the radius is 9. So that's pi times 9 times the slant height. Now here's your L, that's your slant height. We do not have that. So we're going to do Pythagorean theorem. Look at the right triangle. So we would do a squared plus b squared equals c squared. We can do that on the side here. Actually, I'll do it down here. 12 squared plus 9 squared is L squared. And if you add this up, you're going to get 225 is L squared. We take the square root, and we get 15 is L. Okay, so I'm going to put a 15 in there. Now for your answer, you're going to do 9 times 15 times pi. If you just do the 15 times the 9, you get 135 pi. If you decide to type that into the calculator, and you can type pi times 9 times 15, you get the decimal, which is 424.1. Either answer is good. This is exact, this is rounded, but they're both good. So that's your lateral area. Let's say that this is inches. Okay, so this would be inches squared because it's an area. So that's your lateral area. That's just this part of the cone here. It does not include the circle at the bottom. It's not the base. Now let's see, surface area. So on our formula sheet here, the surface area is pi times radius squared. That's one base. That's the one circle area plus the lateral area, pi times r times L. So I'll write that down. Pi r squared plus pi times r times L. And in this case, we already know the radius is 9. And again, radius is 9, slant height is 15. And we already knew this. This was 135 pi. And then 9 squared is 81. So that's 81 times pi. You can add these up. If you add the 81 and the 135, you get 216 pi. Now that's a good answer. If you type that into the calculator, you will get 678.6. And again, this is an area, so it's the units of measurement squared, inches squared. The last one is the volume. Okay, so volume of a cone, 1/3 pi r squared h. Notice that the pyramid was 1/3 times the area of the base times the height. The area of a circle, that's the base, is pi r squared. So it's the same formula. Volume is 1/3 pi r squared times height. Same formula, but now you're talking about a circle. So we're using radius instead. The radius, they tell us, is 9. The height, they give us, that's the 12. So that's the height of the cone. So that's 1/3 pi times 81 times 12. So if we do 1/3 times 81 times 12, so if we ignore the pi right now, we'll get 324 pi. But if you want to keep it as a decimal, that's 1017.9. And because this is volume, the units of measurement would be inches cubed. And that's the end of the notes.